Hello students, let us begin this video with the topic power of a lens, and also it is consisting of power of a combination of lenses. This video also consisting of some previous year question which is based on numericals. Okay, so let us start. The very first topic, first let us understand what is the power of a lens. It is saying, the definition saying, the degree of convergence or divergence of a light ray is expressed in terms of power. Okay, so that means the more is the convergence or divergence, more will be the power. Okay, convergence or divergence means what here? Suppose here I have taken one of the concave lens. Okay, concave lens, ये हो गया प्रिंसिपल एक्सिस. सपोज ये एक लाइट रे ऐसे जाता, ये यहाँ पे फॉल हुआ है, इट हैज़ टू गो स्ट्रेट, बट इंस्टेड ऑफ गोइंग स्ट्रेट इट हैज़ गॉन, it diverges. So ये जो एंगल बनाया, that is what? That is the divergence of the light ray. I hope it is clear. Similarly for convergence, मैं यहाँ पे एक कॉन्केव लेंस बनाती हूँ. उसका ये हो गया प्रिंसिपल एक्सिस. एक लाइट रे आया, इट इज़ सपोज टू गो इन अ स्ट्रेट पाथ लाइक दिस, बट सपोज ये उसका फोकल लेंथ है यहाँ पे 20. ओके, इट इज़ 20 सेंटीमीटर. सो इट हैज़ कन्वर्जेस लाइक दिस. और एक मैं कन्वेक्स लेंस लेती हूँ सेम, बट हियर द चेंज इज व्हाट? अनदर, द फोकल लेंथ इज हियर 50 centimeter. Okay, it is 50 centimeter. So the light ray came, it is supposed to go straight like this, but instead of going like that, it converges like this. Okay, so this is another angle. This is angle, this is theta, and this one is theta 1. Okay, so in this, if we'll compare these two, what will happen? Theta is more than theta 1. Okay, you can see that it is converges in the first case, in case 1, and this is case 2. In case 1, this angle is, by making more angle, it converges little early, because the distance, this distance is less than that of this distance. So it has to, instead of going straight, it has to converge more to get through this focus. Similarly here, in the case 2, what is happening? Instead of going straight on this path, it has to converge a little late, because the focal length is at a distance of 50 centimeter. I hope this one is clear. So what you are getting here, the convergence is more, so power becomes more, right? Here convergence is less, so power becomes less. And this is happening why? This too is happening why? Because in this case the focal length is less. In this case the focal length is more. Okay, so we are talking about the power of a lens. So what we concluded? We concluded that the power is inversely proportional with the focal length, right? So we can conclude this formula. It can be formulated like this: P equal to 1 by F, but this F has to be in terms of meter. I hope you are clear this one. Okay, one more thing you have to remember, that the unit, the SI unit of power is what? It is diopter. Okay, so now just see, in the first case we had taken that focal length is 20 centimeter. We have the formula what? P equal to 1 by F. So here for the first case, if I'll write 1 by this F has to be in meter, but in the question it was given 20 centimeter. So what I have to do? I have to convert it into meter. It is 0.2 meter. So by calculating, what it will be? It will be 10 by 2 equal to 5 diopter, because the unit is diopter and we have to denote it with capital D. Similarly for case 2, what it will be? It is 1 by 0.5 meter. So this becomes 10 by 2, and it becomes, sorry, it becomes what? It has to be 10 by 5. So it will be 2 diopter. Okay. So in the first case we saw that the power is more. So here you got the value more. Here in the second case we got that because of the focal length was longer, I mean the value is more. So that is the reason the power is also less. I hope this one is clear. Now here you can see that in the power, the value we got is plus 5. So this positive sign indicates that it is a convex lens, and we have calculated this entire thing for a convex lens only. That is what the next point is. Power of convex lens is positive, and so as the power of convex lens is negative, because we know that focal length for this is positive and focal length for concave lens is what? It is negative. I hope this one is also clear to you all. So let us move on to the next part. So here just I have written how it has been formulated, how it has been related. So from this you can say that this P equals to 1 by F, and this is the formula. So next point is saying clearly we know that the smaller is the focal length, greater will be what? The power, and vice versa. So as it is the inversely proportionate, so you know what can be the relation in between them. Now next is saying what? The power of a lens. Okay, power of a lens is for a convex lens. What we can write for a convex lens? F is positive, and therefore P is positive, and power of a convex lens is also positive. Okay, so what does it mean? We know that P equals to 1 by F, 1 by F, and if F is positive, that means F value is positive, so we can say that the value of power is also positive. Okay. Similarly, in the next point, the concave lens F is negative. We know that F is negative, hence the value of, the sign is negative in case of concave lens. Okay, the power will be also negative because the focal length is negative. Okay, now it means a concave lens would diverge the ray of light falling on it instead of converging them. Okay, this one you got it already, I explained. Next point is saying SI unit of power of a lens is diopter. It is represented by D. So here we can formulate it. Everything we had done. Suppose if F value is 1, what will be answer? What is the power? 1 by 1 becomes how much? It is 1, and power becomes 1 diopter. Okay, so next let us see next what it is saying. 1 diopter. Basically this particular definition comes. What do you mean by 1 diopter? 1 diopter is what? It is the power of lens of focal length 1 meter. Okay, as I told you, it is we have to write in terms of meter. So this power of instrument can be measured directly using an instrument called dioptometer. So the instrument name is, it has been given, you need to remember that also. Power of lens in diopters is called the number of the lens. That means what? When we got P equal to 5 diopter, means this number is the what? It is the number of the lens. Like the way in case of spectacles we say a number, isn't it? That is the power of that particular lens. So focal length, next point says focal length of a lens is given in centimeter. मैंने अभी कहा कि जो हमने ये फॉर्मूला लिखा था P इक्वल टू 1 बाई एफ, एंड दिस F इज़ इन टर्म्स ऑफ मीटर. बट तुम जानते हो जो फोकल लेंथ हमें क्वेश्चन में गिवन होते हैं वो सेंटीमीटर में गिवन होते हैं. तो हमने क्या किया था, ये F को अगर 20 सेंटीमीटर हमें क्वेश्चन में दिया था, हमने उसको 0.2 मीटर करके कन्वर्ट करके लिखा था. इंस्टेड ऑफ कन्वर्टिंग दिस डायरेक्टली वी कैन ऑल्सो राइट दिस वन. ओके, ये देखो जैसे हमने उसको अल्टरनेट करके लिखा था. जैसे पहले के लिए फर्स्ट केस के लिए हमने निकाला था जब हमारा फोकल लेंथ था 20 सेंटीमीटर. इन दैट केस वी गॉट द पावर एज 5 डायप्टर. अभी उसी को हम डायरेक्टली डालते हैं. यहाँ पे देखो 100 बाय वॉट एवर इज गिवन इन द क्वेश्चन. सपोज फोकल लेंथ दिया है 20 सेंटीमीटर. सो डायरेक्टली ये सेंटीमीटर में ये फॉर्मूला में ऊपर जो न्यूमरेटर पार्ट है वहाँ पे 1 नहीं लिखे, हम लिखेंगे डायरेक्टली 100. सो हियर वी कैन राइट 100 बाय 20, दैट्स इक्वल टू 5 डायप्टर. अगर तुम इसे काटोगे तो वही तुम्हारा 5 डायप्टर आंसर आ जाएगा, isn't it? So either you can write the previous formula in terms of this one, this particular one, the one I told you, or this one directly, but you just remember that this is the original formula. In terms of centimeter, when you are writing, the numerator has to be 100. I hope this one is clear. Now, the next topic is power of a combination of lenses. Power of a combination of lenses means what? P equals to, it is the number of, number of lenses when we are combining. Suppose we have taken one concave lens, a convex lens, then a concave lens. Okay, another concave lens, whatever convex lens, sorry. Suppose this, the power of first one is P1, this is P2 and P3. Whatever is the power, we have to just add all the power, and we will get the combination of the power of the combination of lenses. This is the formula I mean to say. If P equal to the power of the combination of lenses, if this is the P, this entire combination is P, then we can just add the individual power of individual lenses power, and so we are going to get the power of the combination of the lenses. I hope you are clear in this. So the algebraic sum we have to calculate. Suppose the first case, in the first case, this is the power is 3, this is 7, this is 2 suppose. So what we can write, it is the simple summation, addition I told you. So it has to be 3 plus what? It has to be minus 7, because it is a, it has to be minus 7 because it is what? It is a concave lens and the focal length is minus. So the power of concave lens is also in negative. And last one is how much? It is 2. So it becomes what? It is minus 2 diopter. Okay, it is minus 2 diopter. The answer is minus 2 diopter. Clear? Here the minus sign indicates that what? It is a concave lens. Okay, concave lens means the entire combination will behave like a concave lens. I hope this part is also clear to you all. Here another example it has been given. Suppose here the sign is already been given. So here the power, it is given that the power of a convex lens is plus 5 diopter in contact with the concave lens of power minus 2 diopter. So we have to just simply add it. So for suppose this one is 5 is P1 and minus 2 is P2. So just put the values and you will get 3 diopter. Because it is a plus sign, so it will behave like what? It is a convex lens. Okay. So let us move to the first numerical. First numerical says what? A concave lens has a focal length of 50 centimeter. Calculate its power. Either for this children, we can use any of the formula, like either you convert this. We have already done this one because it is a concave lens. First you have to remember f equal to how much? It is minus 50. Okay. First you have to remember. If you want to directly put this value, so you have to take power formula as 100 by f in terms of centimeter. So just put the value 100 by 50. That becomes 50 means here it is minus 50. That becomes what? Minus 2 diopter. This is the answer. This is the answer. Okay. So let us move on to the next one. Here a thin lens has a focal length of minus 25 centimeter. What is the power of lens? Is it a convex or concave lens? So children, just see, from the first line only you got one of the answer. That is whether it is a concave or a convex. Which one? This focal length is given as negative. So it is a what? It is a concave lens. Right? So just simply this is in the question, whatever is given, first you write that. Now I think this part you just omit. You just write formula over here and then put the value and you will get the power is as minus 4 diopter. Okay, and negative sign shows that it is a concave lens. Clear? Now the next one, these are quite easy. Next question, just see here. Try to do it by your own first, children. After that you move on to the solution which is already been given to you. Just see the questions. What is it is saying? Converging lens. Converging lens means which lens? It is the convex lens, right? So it is the power is what? Convex lens power is 8. So it has to be positive. Let us take it P1, which is combined with a diverging lens. Diverging lens means what? Which lens? It is a concave lens. So P2 is minus 10. Here the sign has been given in some of the question. It may not be given to you. So just remember that part. You need to remember which is this converging lens, which is diverging lens. All those you need to remember. Calculate the focal length now. First of all, we have the individual power. So let us find out the final power, that is P equal to P1 plus P2. That gives you minus 2 diopter. Now we know that what? P equal to 1 by f, which implies what? F in terms of meter, I mean to say, in terms of meter. So if we have to always find out this in terms of meter, actually this answer, because we in the question it has been given the diopter, and diopter has to be in terms of meter. So f equals to what? It has to be 1 by p. So that's equal to 1 by minus 2, which gives you minus 0.5 meter. In this case, it will be better if we will not use that 100 by f in terms of centimeter, okay, because you will not get it directly. So go with this. Whenever the power is been given and you have to find the focal length, you go with the formula P equal to 1 by f in terms of meter 1. Okay, I hope this one is also clear. Now the next question is saying that the focal length and the nature of lens which should be placed in contact with a lens of focal length 10 cm so that the power of the combination becomes 5 diopter. That means one of the power is given and the final power is been given. P is given, okay, P is given. Suppose let P2 is also given, okay. So P2, how you can calculate? Because focal length is been given. If focal length is been given, one focal length we have to find out, another lens focal length is been given. So power of the second lens is we can calculate by 100 by 10 centimeter, which is 10 diopter, okay. The total combination of that lenses power is been given, that is 5 diopter, it is given. So P1 plus P2 is P, we know the formula. Now P1 we have to find out, and P2 we already got, that is 10 diopter, and final is what? It is 5. So just after calculating you will get P1s minus 5 diopter. So that means P1 is what type of lens? It is a concave lens, okay. So now for this particular lens, what is the focal length? So P1 F1 equal to 100 by P1 we have done here, because it is centimeter. So that is the reason it has been written this particular formula, 100 by P1. 100 minus 5 will becomes this much. What? This will becomes what? 20. This 20 will come in terms of centimeter. Okay, it is in centimeter, because in the question, half of the question, it is we are in the one of the lens it has been given 10 centimeters. So directly we are to get this particular value in terms of centimeter. We need to use this particular 100 by this P1 formula we have to calculate it. In case suppose you will take 1 by P1, then whatever will be the value you will get, that will be what? In terms of meter. Again you need to convert it into centimeter, because in the question it has been given in terms of centimeter, right? So in this case, children, don't get confused in the board exam. You just write both of them to get the full marks, okay. So lens must be concave. It has been understood. Lens must be which one? It will be going to behave as concave lens, because this particular lens, I mean this second the one we are not getting it, I mean the question, in the question which one is not given, that is P1. It is talking about the P1, okay. P1 is behaving as a concave lens, okay. So nature of the lens it has asked, because it is a concave lens, we can say the nature is diverging. Clear? I hope, because it has been given what is the nature in the question. Just see, nature of the lens it has been asked. So you have to write the nature is whether converging or diverging. If it would have asked that what type of lens, then you will write concave or convex lens, okay. So let us move on to the last question of this video. So just go through the question properly, carefully, because here you can see there is a ray diagram. We need to remember, we need to understand the question first. It is saying that if the image formed by a lens for all position of an object placed in front of it is always erect and diminished. Erect means what? It is a virtual one, isn't it? It is a virtual one, and virtual we get in case of concave lens only. So what is the nature of this lens? It is concave, because it is erect means it is a virtual one, and erect and diminished we always get only in case of concave lens. You have to write like that, and it is the nature is what? It is concave. Concave means what type of nature it is? It is converging. In case of lens, it is concave means what? It is diverging. Okay. So draw a ray diagram to justify your answer. It is asking about ray diagram. Then if the numerical value of the power of the lens is 10 diopter, what is the focal length in Cartesian system? Okay, Cartesian system means just you have to write in terms of meter, centimeter and calculate it. When the image, solution में क्या लिखा है देखो, when the image for all position of an object is always erect and diminished, that means what? It is a concave lens. Lens is concave. So what is the nature? It has been asked, in the question it is asked that what is the nature of the lens? Concave means in case of lens what? It is a diverging nature. Okay, so you have to add one more statement here and underline that because it is the first part of the answer. Okay, in this figure A dash B dash, okay, A dash B dash is the erect and diminished image of AB. This is the object and this is the image, right? So how you have to write? Any position you take, any position of the object you draw, and then it in front of a concave lens, and first one is parallel to the principal axis, and it will diverge, and after refraction it will be appear as if it has come from the focus, right? It is focus. So now you have to just another ray for getting the image, you have to take another ray that is passing through the optical center. Now intersection point is the image position. Image position you will always get what? It is the erect one, because we have taken this first ray as this one. I am talking about the first case in a dotted line, whatever is been given. So one is virtual, that means the entire image we are getting is a virtual one. Okay, so now the point is what is the value of the focal length? So P is been given, that is 10 diopter. Just put the formula F equal to 100 by P, because we want to get the terms directly in centimeter. In case you want to use the formula 1 by P, then in that case again the answer will be in terms of centimeter, and then you have to convert it into I mean that will come 1 by P if you will write. The answer that we are going to get is in terms of meter. So you need to convert it into centimeter, because generally we used to give the focal length in terms of centimeter. Okay. So by convention we know that focal length of the lens is negative. We know that concave lens is always the focal length is negative. So simply you use this as -10. Just see children, here in the power it has not given the sign, so you have to use minus sign over here, right? With this we come to the end of this particular video. That's it for today, and in the next video with some more question with new topic elaboration we will meet. Okay, till then stay safe. Bye bye.